So we're only going to go through the first part of 7.4. Rule number 1 of logs. If you have two logs and they have the same base, if you're going to add them together, you can simplify them to log base b of m times n. If you have two logs, they're added together, you can multiply them if they have the same base. For example, if you have log base 2 of 3 plus log base 2 of 5, it just becomes log base 2 of 3 times 5. If you have two logs with the same base, you're adding them together, you can just multiply those two numbers that's inside. Okay, and then the other one is also true. If you have two logs of the same base, you're subtracting them, then it is the same thing as saying combining into one log, but you're going to divide. First one divide by the second one. So I'm going to use the same numbers again. If you have log base 2 of 3 minus log base 2 of 5, it is the same thing. If you want to combine it into one log, it's log base 2 of 3 divided by 5. All right, let's do some practice. Okay, write the following expression as a single logarithm. So basically, they don't want two logs, they don't want three logs, they just want one log. So you're going to have to combine it together. Number 1, log base 4 of 32 minus log base 4 of 2. Can we combine them together? Yes. Why? Same base. Okay, so what can we do? There's a minus sign, so minus sign says we can divide. Okay, so log base 4 of 32 divided by 2. Okay, you can leave it like that, or you can just simplify it a little bit and leave it at 16. All right, let's try number 3. All right, so this is log base 4 of 15x squared. All right, 2 is pretty much the same example I gave you, so we're not going to do that one. Number 4 requires rule number 3. Rule number 3 says, if you have a coefficient in the front, then what you can do is you can move that coefficient as the exponent of whatever is inside. So this becomes log base b of m to the k. Notice how the levels are very complicated now, so you have to write very carefully. There is a base level, there's a regular level, and there's an exponent level. So please be careful how you write it, so it's very clear. All right. Let us look at number 4. Okay, let's look at number 4. 6 log base 2 of x minus 5 log base 2 of y. First of all, can we combine them together? Yes. Why is that? They have the same base, yeah. Before we combine them together, however, we cannot have a coefficient in the front. We have to move it first. That means the 6 has to go. What can we do with that 6? Move it to exponent of x. So this becomes log base 2 of x to the 6 minus. All right, there's a 5 in front of that log. I have to move the 5 first. So what can I do with the 5? You guys look so tired. Or hungry. Maybe it's hungry. Okay, what can we do with the 5?
Move it to the exponent of y.
Move it to the exponent of y. So log base 2 of y to the 5th. All right, now combine them together into 1 log. So this is log base 2 of x to the 6th over y to the 5th. All right, let us visit these rules, but backwards. Rule number 1. Now, if you see this, we can expand it. So what we did before was we combined all the logs into 1 log. Now, when we see 1 log, we can expand it. Okay, so if you see this, we can, so basically if you see a multiply in between, we can expand it so that they're adding to each other. Okay, if you see a multiply, it means split it and add them together. Same thing as rule number 2. Rule number 2, if you see a divide, it is the same thing as expanding it and subtracting. Okay. All right, and then rule number 3 is the same. So if you see an exponent, you can move it in the front. This rule is actually really helpful, the exponent one. All right, so let's practice expanding. Let's go to the next page. Oh, are you guys good? Did you guys copy everything down? Okay. We're going to finish rules 4, 5, 6, 7 right now. We are on page 7. Okay, rule number 4. Log base b of 1. Log base b of 1. Okay, so remember that we can just do the loop rule to find out what that number is. So the loop rule, so if you think of it like this, you go around. So b to the x is 1. b to the x is 1. What number must x be? 0, right? The only way you can get a 1 is if the exponent is 0. So then this is 0, which means anytime you see a log of 1, it's always 0. Log of 1 is always 0. Doesn't matter what the base is. Okay, next one. Log base b of b equals something. Okay, so if you don't remember, so I'm going to give you the rules, and then it's easier if you memorize the rules. If you don't memorize the rules, you can always do the loop. Okay, so this is b to the x is b. b to the x is b. So what does x equal to? 1, right? It has to be 1. So basically, if you have a log base b of b, it's just 1. If the base and the base are the same, it's just 1. And it's actually related to the next rule. So if we loop around, b to the x is equal to b to the k. What does x equal to? K. So here's the rule. If you have a log base and then the exponent has the same base, they just cancel. So you just get a k. And then you can actually apply to this previous rule. It's really b to the first, and then that just cancels, so it's just 1. Okay, so log base, and then of the same base, the base just cancels, and then that log goes away. Okay, last one. This one's really strange looking because this one, if you can see, you have like 3 different levels like this. There's a b to the log base b of k. So it's pretty crazy with all those lines there. Okay, if you have a base and the log has the same base, it just all cancels and you get a k. All right, let's go to the next page. We're going to practice rules 5, 6, and 7. Yes? Huh? Oh, okay. I'll show you the notes later. Okay, let's expand this. Log 4x over y. Well, we can read this as log of 4 times x divided by y, right? 4 times x. So if we wanted to expand that, would that be an adding or a subtracting? 4 times x. 4 times x. Is that going to be adding or subtracting? Adding. So that's going to be log of 4 plus log of x. And then we're dividing by y, right? So dividing by y is the same as expanding and add or subtract? Subtract. Are you guys okay? Okay, if you cannot see this, what you could do is see that you basically have 2 things that's divided by each other, right? So you could just think of it like this: log of 4x minus log of y. And then ask yourself, can I expand it more? Well, yes, 4 times x, I can expand that again. So then you can just do this. Okay, so if you cannot see multiple steps at once, this is what you can do. See it as, oh, just one division. Oh, I have more later. All right, let's have you try one. And then we call it a day. Okay, number 3. Okay, and then you can go one more step. All right, so let's go ahead and look at these rules. So I'm going to help you with a few of them, and then you're going to finish the rest. Log base 2 of 2, using the rules from the previous page. Log base 2 of 2 is what? 1. Okay, so basically there's an invisible 1 there, and all cancels out, so you get a 1. The log goes away as well, okay? Log is gone. So log base 2 of 2, that whole thing is gone. You end up with a 1. Okay, rule number 2. This one's a little bit trickier. 3 log 10. 3 log 10. Okay. All right. So you're banned from answering for a few seconds. Okay, 3 log 10. If that log has no base, it means a base of 10. So this is a log base 10 of 10. Log base 10 of 10 is 1. Log base 10 of 10 is 1. So it's just 3 times 1, which is 3. Okay. All right, so you're just trying to see if you can try to get the same base so then you can find the answer faster. Anyways, let's go ahead and have you do the rest. 3 through 8. 3 through 8. All right, let's go over the answer. Giselle, can you do number 3? 8, good. So log base 3 of 3, that cancels, is just 4 times 2, which is 8. Andrew, number 4.
I got 2.
Yes. So log base 5 of 5 squared. 25 is 5 squared, so that's gone. So it's just 2. Chad, number 5.
3.
Yes. So this is an invisible base 10. So this is log base 10 of 10 cubed. So that is gone. So it's just 3. Okay. Sebastian, number 6.
3.
Yes. So the whole thing cancels. Just 3. Andy, number 7. 2. Same thing. Whole thing cancels. Alana, number 8. Yeah. So this same thing, the whole thing cancels, just 9. Good? Okay. Let's do this one. I'm going to show you how to do logs in your calculator, so make sure you have a calculator today. Log base 5 of 36. Let's look at number 1. Log base 5 of 36. Most of our calculators don't have the function to actually put in log base 5 of 36. Most of our calculators only have two things. It's either log or there's another thing that says ln, which we'll do next week. Okay, so if we have to figure out what this number is, if we do the loop rule, we do 5 to the x is equal to 36. 5 to the what is 36? A little bigger than 2, a little smaller than 3, a lot smaller than 3. Right, so we don't know what that number is. What we can do is we can do this thing called the change of base. Change of base says if you have a log of base b of m, what you can do is change it so it's log of m over log of b. Log of m over log of b, and then we just use the same base for that log. And we don't use base b, basically. That's what we're saying. Or in general, we can use any base we want, just not the base that we started with. Okay, for example, the one we just did. All right, let me write this on the side. Log base 5 of 36. Okay, because we couldn't figure out what that number is and we want to use our calculator, but our calculator doesn't let us choose a base 5. So what we're going to do is change of base. We're going to do log 36 over log 5. So log of whatever's inside divided by log of the base. All right, you're going to put that in your calculator and figure out what that number is. But I need to warn you, your calculator is too smart, but you are smarter, so then you have to overcome the calculator's problems. So what happens is if you put in log, it will automatically have a parentheses. You're going to put in 36, but you need to close parentheses. If you don't close it, your answer will be totally wrong. And then you're going to put a divide sign, and then log parentheses 5, close parentheses. Okay, so go ahead and use your calculator. If you don't have a calculator, let me know. I'll lend you one. All right, Alice, what did you get for the answer? 2? 2.23, good. All right, let's have you guys do 2 and 3, and let me know when you're done. All right, Evan, what did you give? What did you get for number 2? 1.67. Nathan, what did you get for number 3? 2.08. Good. All right, now let's practice. First two, we're going to combine it into one single logarithm. Okay, I need to tell you a few things. When you combine it into a single logarithm, the first thing you always want to do is move coefficient. If there is a coefficient, you have to move it as an exponent first before you can combine it. If you don't, it will be entirely wrong. The second thing is combine logs. If they have the same base, okay? If they don't have the same base, you can't combine them. All right, go ahead and try 1 and 2. Samantha, number 1.
Log 4 of 16.
Log 4 of 16. There's something wrong with that phrase. You mean the 4 is a base. Yeah, log base 4 of 16. Okay, so if you leave it like that, it's correct because it just says single logarithm. If you have to go farther, you can get this number to be 2. because 4 squared is 16 if you do the loop rule. But if it just says single logarithm, this is good enough. All right, number 2, Josh.
Log base 6.
Of 6. Huh? Is this what you have? Okay, so if it says combine into one single logarithm, this is good. Or if you go one step further, you get 1. All right, let's try expanding. All right, expanding, we're going to go backwards. So this is the rule. First thing you have to do is expand. Then if you have exponents, then move exponents as coefficient. So the first thing you do is if you see a multiply or if you see a divide, you expand it into different logs. And then if you see exponents, then you move it to the front. Do not move all the exponents to the front first because that is totally wrong. Okay? All right, let's go ahead and have you do 1, 2, 3, and then 4, I'm going to kind of help you get started on that one. All right, let's do this. Isabella, what'd you get for number 1?
Log base 3 of x minus log base 3 of y.
Mm-hmm. All right, number 2. Daniel, you have the hard one. Wait, base of? No, the base is not m. The base is just 10, but so we can just ignore that base. Okay, so m, and then? Yes, good. All right, so make sure you expand first before you move the exponents. All right, number 3. Brady, you want to do this one? You didn't do this yet. Did Mark do this one? Not yet. Okay, did anyone do this one? You want to share your answer? Yeah.
I did.
Okay, go ahead.
Half log base 2 of x.
Yes. So the square root x is just x to the 1/2. So just move that 1/2 to the front. So just a little bit of review from, a little bit of review from last semester. All right, number 4. Write log 150 as a sum or difference of 2 logs. So you're going to split log 150 into a log plus another log or a log minus another log. But then you have to get 150. Okay? So go ahead and write down, everyone, please write down one answer, whether it's sum or difference. All right. Mark, did you write one down? No? Brady, did you write one? Okay, what'd you get?
Log 15 plus log 10.
Okay, good. Log 15 plus log 10, good. All right, Sally, did you get another one that's different? Plus log 15, okay, good. Did anyone get anything that's a difference of 2 logs? Besides Sebastian. Something divided by something gets you 150 and then expand it. Yeah.
Log 10 plus log 10 plus log 3 minus log 2.
That is good. However, it just wants 2 logs.
Oh, so
Yeah.
log 300 minus log 2.
Okay, log 300 minus log 2. Yes. If you combine them together, it's going to be 300 divided by 2, which is 150. Okay, good? All right. Okay, we're going to do this part really quickly because you already know how to do this. 16 to the 3x, so we're on the next page. 16 to the 3x is equal to 8. How do we solve for x? First of all, try to look for something that's simple, right? Can we change 8 and 16 into the same base?
Yes.
Yes. What would be the base?
2.
2. Okay, so 16 is 2 to the what power? 4. So 4 times 3x. And then 8 is 2 to the what power? 3. All right, because they have the same base, their exponents must equal. So this is 4 times 3x equals 3. So that is 12x equals 3. X is 3 over 12, or 1/4. Easy. Right, so as long as you can tell whether they have the same base or not, you can solve this pretty easily. Okay, so let's go ahead and have you practice 1 and 2. All right, number 1. Allison, what'd you get? 4 over 9? Okay. Yeah, so 27 is 3 to the 3rd, so that times that 3x there. 81 is 3 to the 4th, so then we make them equal to each other, 4 over 9. Trey, number 2.
-5/3.
No. Okay. So this 1 over 125 is the problem, right? So 125 is 5 to the what power?
-5.
Just 125. 3. So 1 over 5 to the 3rd. So this becomes 5 to the -3. So then 3x is equal to -3. And x is equal to -1.